Hey everyone, in this video I'm going to discuss name reaction. Okay, so basically this is the first class for your name reaction, and first I have just tried to understand you that what is condensation reaction. Okay, so reactions in which two molecules combine together to form a large molecule with the elimination of some molecules, small molecules such as water, alcohols, etc. Okay, this is called condensation reaction. Basically alcohol, water or HCl are elimination in this reaction. Okay, and two molecules combine together. Okay, before proceeding further, the understand some terms. Okay, in this part the questions are asked in PGT chemistry. Okay, so I just discuss in this section what is enol, what is enolate, what is ketoenol tautomerism, and what is aldol reaction. Okay, and these parts are very important for your PGT preparation in chemistry. Okay, so first of all you have to know what is enol. The enol is exactly what the name implies, that is in all. Okay, in means a double bond and all means OH. Okay, so an enol has a carbon carbon double bond and an OH group joined directly to one of the sp2 carbon. Okay, so this is the basically the structure, that is a double bond directly attached to OH group, and this double bond, that is sp2 carbon, is attached directly to OH group. This is in all. Okay, so next, what is enolate or enolate ion? When an alpha hydrogen is removed from a carbonyl group in an acid base reaction, resulting resonance stabilization carbanion is known as enolate ion. Okay, so basically if a base is present in the reaction, so base attracts the hydrogen and the hydrogen molecule attached by base. Okay, so here a negative charge is generated. Okay, so this negative charge is resonance through this carbonyl group and an enolate ion is formed. Okay, so enolate ions are stabilized by resonance. Okay, so these are very much stable. So here one resonance form has a negative charge on oxygen atom and other has a alpha hydrogen atom, alpha carbon atom. Since charge of enolate anion is delocalized, an enolate anion is more stable than a carb anion. Okay, so such as CH3 CH2 minus ion is in which no resonance, so stabilization is possible. Okay, so basically in this portion I just simply tell you that the carb anion are less stable than enolate. Okay, so enolate anions are more stable through resonance the negative charge to carbonyl group. You have to note 1 2 3 portion. Okay, so the alpha hydrogen of aldehyde or ketone is nearly 10 to the power 30 times more acidic than the CH bond of alkanes, whose pK values are near about 50. Okay, so the tremendous difference in acidity reflects more than inductive effect of carbonyl group. Okay, next point, the major contributor in resonance form of enolate ion is having negative charge on an oxygen atom. Okay, so the if we just an example, that is a double bond with a CH3 group, that is if base is present, then base attacks the hydrogen atom and there is negative charge, and this negative charge is a resonance through the double bond. Okay, so this resonating structure is possible. But if there is a carbonyl group with a CH3 carbon, then this if the base is present here in this reaction, then negative charge is delocalized through carbonyl group and this is more stable. Okay, next, enolates are ambident nucleophiles because they possess two nucleophilic sites, each of which can attack an electrophile. Okay, because the double bond and the oxygen group. Okay, oxygen atom with negative charge. there are two possibility in this reaction. Okay, when oxygen atom attack an electrophile, it is called O attack, and when carbon atom attacks with E plus, then it is called C attack. Okay, and these are two availability of this enolate. For simplicity, we draw mechanism like this, that negative charge will attract E plus, and this is the formation. Okay. Next points, enolates are more useful than enols for reaction because first point is enolates possess a full negative charge, and therefore they are more stable, more reactive than enols. Okay, and secondly, enolates can be isolated and stored for periods of time. Therefore, majority of reaction of carbonyl groups proceed via enolate intermediates. Okay, so basically there are some points why enolates are more stable than a alkene with a negative charge. Okay, so what is ketoenol tautomerism? And this is the very much important for your exam point of view. The conversion of a carbonyl compound into its enol form is known as enolization. Okay, so basically uh, carbonyl compound when generates a enol. Okay, and this is enolization. In such reaction, a proton is lost from carbon and gain on oxygen, and thus we see that product is almost same as the starting material, since the only change in the transfer of one proton and shift the double bond. Okay, so basically products is same, but the ketoenol tautomerization is uh, is in the intermediate form, it is generated. Okay, so here a ketone and an enol are isomers, and they are given the same tautomers. Okay, name tautomers. We can call these two are, this is towards tautomers. Okay, so what are the tautomers? Because the tautomers are the isomers. Okay, and the groups are changed. Okay, the hydrogen atom is here. Okay, the interconversion of tautomerization is called tautomerization, ketoenol tautomerization. The important things to notice is that the keto and enol tautomers exist in equilibrium in the solution. Okay, and largely lies in the left side. Left sides because this is enol formation. This is keto formation. Okay, why don't simple aldehydes and ketones exist as enols? Okay, simpler carbonyl compounds like cyclohexanone or acetone have only added trace of enol present under ordinary condition, ketone form of acetone. Okay, and this is very much important, very stable than enol form of acetone. Okay, reason, this is because the combination of a double bond and an OH single bond is slightly less stable than the combination of a C double bond O and a CH single bond. On the other hand, the OH group bond is enol is a stronger bond than the CH bond in the keto form, but C double bond O bond of the ketone is much more stable than the C double bond C of enol. Okay, so in this class, I will discuss what is enol, what is enolate ion, and what is in ketoenol tautomerization. Okay, and these are the very important from your exam point of view. Okay, you have to read it.